Mastering artificial neural networks. Activation functions ignite neural networks, unleashing predictive power from complex data. Where does the activation function fit in the artificial neural network, and what specific role does it play in enabling the network to learn and make predictions from complex data sets? In an artificial neural network, the activation function plays a crucial role in enabling the network to learn and make predictions from complex data sets. The activation function is a mathematical operation that is applied to the output of each node or neuron in the network, and it determines the output of that node. The activation function is typically located inside the node or neuron, and it takes the weighted sum of the inputs to the node as its input. The weighted sum is calculated by multiplying each input with a corresponding weight, adding up the products, and then adding a bias term. The activation function then takes this weighted sum and maps it to an output, which is the output of the node. The specific role of the activation function is to introduce nonlinearity into the network. This is necessary because most real-world problems require the network to learn complex and nonlinear relationships between the inputs and outputs. Without an activation function, the network would only be able to learn linear relationships, which are not sufficient for many applications. The activation function serves several purposes. 1. Introducing nonlinearity. As mentioned earlier, the activation function introduces nonlinearity into the network, allowing it to learn complex relationships between the inputs and outputs. 2. Enhancing expressiveness. The activation function increases the expressiveness of the network, enabling it to learn and represent more complex and abstract concepts. 3. Enabling the network to generalize. By introducing nonlinearity, the activation function enables the network to generalize better to unseen data, allowing it to make more accurate predictions. 4. Controlling the output range. The activation function can be used to control the output range of the node, which is useful for stabilizing the training process and improving the overall performance of the network. There are several types of activation functions, each with its own strengths and weaknesses. Some of the most common activation functions include 1. Sigmoid. The sigmoid function maps the input to a value between 0 and 1, which can be useful for binary classification problems. 2. ReLU, rectified linear unit. The ReLU function maps all negative values to 0 and all positive values to the same value, which can be useful for introducing nonlinearity and speeding up the training process. 3. tanh, hyperbolic tangent. The tanh function maps the input to a value between -1 and 1, which can be useful for modeling complex relationships between the inputs and outputs. 4. Softmax. The softmax function is often used as the output layer activation function in classification problems, as it ensures that the output values are all positive and add up to 1. 5. Leaky ReLU. The leaky ReLU function is a variation of the ReLU function that allows a small fraction of the input to pass through, which can be useful for avoiding dying neurons. 6. Swish. The swish function is a recently introduced activation function that has been shown to be more effective than ReLU and other activation functions in some cases. In summary, the activation function is a crucial component of an artificial neural network, allowing the network to learn and make predictions from complex data sets. By introducing nonlinearity, enhancing expressiveness, enabling the network to generalize, and controlling the output range, the activation function plays a vital role in enabling the network to learn and make accurate predictions.